what you see here is a drawing of a beam, and usually what we do is we put stirrups close to each other to resist shear, and that's what I mentioned here. Stirrups closer together as shearing force increases. So you can see that the stirrups they close to each other, and then as we move away from, usually you have your column here, so as we move away from the column, the spacing stirrups at maximum permissible spacing, so the space increase between the stirrups, and then that's just to prevent shear. That's why you put your stirrups close to each other. Now you have another point where we say bend up bars to assist in resisting shear force. So what people do is um, they bend the bars to resist shear as well, and then you have your hanger bars to support your stirrups. These they don't usually have a purpose in your beam, because usually your beam is in tension at the bottom, except for when you are doing continuous spans or continuous beams. That's the only time when you have tension at the top of the beam, and when you design uh, for steel in that area. Now let's see what else we have. Okay, I'm just gonna read out what the notes state. So the shape and size of the stirrup may be the same, but the spacing may vary to suit the change in the magnitude of the shearing forces along the beam. These are greater near the supports, so the stirrups are close together there. Sometimes stirrups alone cannot counteract the shearing forces in the beam. In such cases, bend-up bars are used. And yeah, that's basically what you do when you design beams, like when you try to resist shear in a beam.